In this video, we're going to look at a question from the 2009 AP Chemistry test, just a few parts of it where we have a reaction mechanism. So we've got this overall reaction between CH4 and Cl2, and it produces products of HCl gas and H2Cl2 gas. And they say that the following mechanism has been proposed for the reaction of methane gas with chlorine gas, and all species are in the gas phase. In D, it asks, in the mechanism, is CH3Cl a catalyst or is it an intermediate? And it's important that we know the definition of each of them because they will sound similar, but they're really different in terms of what their definitions really mean. A catalyst is something that you start with and you end with in a chemical reaction. Okay, so you start with it at the beginning and you have it at the end. And then an intermediate is a substance that you produce along the way, but then before you get to the end of your reaction, you've consumed it again. And so it doesn't actually show up at the beginning or the end of a reaction. And so we need to find CH3Cl, and here it is. And I would say that it's going to be an intermediate because it's produced in step 3 but then consumed in step 4. Okay, so CH3Cl is an intermediate. That's my claim, and then now I'm going to give you my evidence and my reasoning. It's produced in step 3, but is then consumed in step 4. Thus, matching the characteristics of an intermediate. You may also say CH3Cl is not present in the start or end of the reaction. Thus, CH3Cl cannot be a catalyst. That'd probably be overkill to say that, but if you had the time, I would put it. Okay, now, in E, it says identify the order of the reaction with respect to each of the following according to the mechanism. In each case, justify your answer. Okay, so what we want to do is essentially find the rate law. And you should have learned at this point in the unit that the rate of a reaction is going to be dependent upon the rate determining step. And the rate determining step is fancy language for the slow step. So what I want to do is I have elementary reactions here for my mechanism. And when that happens, you can say that the coefficients in an elementary reaction are going to be equal to the orders. So I'm going to write the rate law for step 2 because that is the slow step, and I'm going to see how far that gets us. So the rate law is dependent on the slow step. Oops. Of the reaction. Okay, so the rate is going to be equal to the rate constant K, and we have CH4 and Cl, so CH4 to the first power, and then Cl to the first power. Now, this might be a good rate law, but what we've got to check is that we cannot have any intermediates in the rate law, so I'm going to write that. Rate laws cannot include any intermediates. So let's see if CH4 or Cl are intermediates. The way I know if they're intermediates is if they're produced in a previous step, and obviously they're consumed in step 2. So Cl, I believe, is an intermediate because it's produced in step 1 and then later consumed in step 2, and it's also consumed in step 4 and step 5. So that's not a good rate law, so we need to substitute. So because Cl is an intermediate, we must substitute from the previous step. And according to the previous step, we have Cl squared equals Cl2, and Cl2 is not an intermediate, it's just a reactant. So we will say that Cl squared equals diatomic chlorine, but all I want to substitute out is 1 chlorine. And so since chlorine is to the second power here, we're going to have to take the square root of each side, and what we're going to get is Cl equals Cl2 to the 1/2 power. So when I substitute, after substituting, the rate law is rate equals K CH4 and then Cl2 to the 1/2 power. So to answer the question is part 1, the order with respect to CH4 is 1. And then in part 2, this is kind of weird. You can have decimal or fraction orders. It's rare, but it does happen. The order with respect to Cl2 is 1/2.